If the path difference is odd multiples of lambda by 2, the secondary maxima is sine theta n is equal to 2n plus 1 lambda by 2. So it's basically if you take n is equal to 1, then it's 3 lambda by 2. This is 5 lambda by 2. And this is 7 lambda by 2. This is so here you can get the secondary maxima for this condition, and the P correspond to the position of central right maximum followed by the secondary maxima and minima both sides. Before I explained that our topic is intensity distribution and diffraction pattern due to single slit. So here we will find out the resultant amplitude, condition for the central maximum, condition for the secondary maximum, condition for the secondary minimum. Again we require that figure 1. This is figure 1. So in this figure, as you know, the incident plane wavefront of the slit AB can be imagined into divided a large number of infinitesimally small strips or small points. The path difference between the secondary waves emanating from the extreme points A and B is A sine theta, where A is the width of the slit, angle ABL is equal to theta. As one coincide the secondary waves in a direction inclined at the angle theta from the point B upwards, the phase difference changes and hence a path difference here. The path differences changes and hence the phase difference also changes. If we consider the alpha is the phase difference between the secondary waves which is generated from the point A and B of the slit, and as you know, the wavefront is divided into a number of small point source, and the resultant amplitude due to all individual small trips can be obtained by the vector polygon. Okay. To understand the vector polygon, first we understand the phasor diagram. So as you know, this is the phasor diagram of the sinusoidal waveform. You can draw a phasor diagram from this wave, like here 0, 30, 60, 90, 120, 150, 180 to 10 up to 360, like this. So similarly here we have taken initially vector OP and this polygon coincide with the circular arc ON. So from the arc OM, you can find the resultant here. This is the resultant. And so this is initial vector, and this is, you know, in the diffraction, the point P prime you got at the inclined angle theta. So that's why this is another vector. This is initial vector, and this is circular arc OM. Actually, this is circular arc OM is nothing but this is a circle with the center K and the radius R. Okay, so radius R and the center K. This is arc OM, and the MN, which is the final vector. And this is polygon coincide with this arc OM. This is final vector. Here the phase difference actually it is phi. So if it is phi by 2 is equal to alpha, so phi is equal to 2 alpha. Here the angle is 2 alpha. Here this is the angle is 2 alpha. This table here also angle is 2 alpha. Okay, so here the angle M and P, M and here is the P is 2 alpha. Therefore the angle OKM is also a 2 alpha. The triangle OKL, if we take the sine alpha is equal to OL divided by OK, OL divided by R. So OL is equal to R sine alpha, okay, where R is the radius of the circular arc. This chord OM is nothing but the 2OL, so 2R sine alpha. The length of the arc OM is proportional to the width of the slit. Width of the slit. OM is proportional to the width of the slit. That's why the length of the arc OM is equal to Ka. A is the width of the slit, K is some constant. Now it can be also a 2 alpha. We can write the 2 alpha is equal to arc OM divided by radius. We can write, right? Arc OM divided by radius. Arc OM is equal to, we know this, Ka and radius R. So 2R is equal to Ka divided by alpha. Okay, so now this 2R, we will put this 2R into equation 1. So Ka alpha is equal to sine alpha. Chord OM is equal to Ka alpha upon Ka upon alpha sine alpha. And again, if we OM is the resultant amplitude, A is the resultant amplitude, so we can write like here, capital A is equal to Ka sine alpha upon alpha. Here Ka, we can write A0. So resultant amplitude due to the vibrations individual point vibrations. A is equal to A naught sine alpha upon alpha. Okay, so now you know the intensity is nothing but the square of the amplitude, square of the resultant amplitude. So you can write A naught square sine square alpha upon alpha square is equal to I0 sine alpha upon alpha whole square. The intensity at any point on the screen is proportional to this function, proportional to this sine alpha upon alpha whole square. Now you know the phase difference of 2 pi corresponds to the path difference of the lambda. Therefore, the phase difference is 2 alpha, phase difference is 2 alpha is equal to 2 pi upon lambda path difference A sin theta, where A sin theta is the path difference between the secondary waves from the A and B, figure 1a. So you can write alpha is equal to pi upon lambda A sin theta. So what these equations looks like sine pi lambda A sin theta, here also pi upon lambda A sin theta. Thus the value of alpha depends on the angle of the diffraction theta. The value of sine square alpha upon alpha square for different value of theta gives the intensity at the point under the concentration. Okay, figure 2 represents the intensity distribution. It is the graph of sine square alpha upon alpha square along the y-axis and the function of alpha or the sine theta along the x-axis. So that graph is nothing but this graph, figure 2. Okay, so now we know the resultant amplitude, intensity and constructive and destructive interference condition for the diffraction. Now we will take the central maximum. Okay, the central maximum is nothing but this one. This is the central maximum. So we will find out the condition for this central maximum. So for the central maximum for the point P on the screen, theta is equal to 0. Okay, and hence the alpha is equal to also 0. That's why the value of sine alpha upon alpha, when alpha tends to 0, this term will equivalent to 1, and the intensity is, if this is 1, then the intensity I is equal to I0, which is the maximum. So if you see this one here, for this P point, theta is equal to 0, that's why alpha is equal to 0, that's why sine alpha upon alpha, sine alpha square upon alpha square term is 1, so I is equal to I0. So this is the maximum intensity point. Okay, central maximum condition. Further, if we look the secondary maxima. So secondary maxima, the condition for the constructive interference, we know that sine theta is equal to 2n plus 1 lambda upon 2a. And you also know the alpha phase difference is pi upon lambda a sine theta. So just put this alpha value, put this sine theta value in this equation. So alpha is equal to pi upon lambda a 2n plus 1 lambda upon 2a. This a will cancel and the phase difference is 2n plus 1 upon 2 into pi. So if you put 1, so this is 3 pi by 2, 5 pi, 5 pi by 2, 7 pi by 2. This is the condition for the secondary maxima. Okay, so if we put this alpha value 3 pi by 2 in place of alpha, then sine 3 pi by 2 is minus 1, and this is 3 pi by 2 whole square for I0 from 9 pi square is equal to I0 divided by 22. If we take the secondary maxima, we put the 5 pi by 2, alpha is equal to 5 pi by 2, then you will get the sine pi by 2 square is 1, 5 pi by 2, 5 pi by 4, I0 25 pi square is equal to I0 61. So it means I0 divided by 22, I0 divided by 61 means intensity decreases. Okay, thus the secondary maxima are of decreasing intensity occur on the either side of the central maximum, that you can understood again from the figure 1. So this is secondary maxima 3 pi by 2, this is second secondary maxima 5 pi by 2, this is 7 pi by 2. So it's continuously decreases. Okay, now for the intensity P prime, so I prime is equal to I0 sine square alpha upon alpha square. So we need to take the derivative because it is changes, right, by inclined theta. So that changes, we take the derivative is equal to I0. So here the simple derivative alpha square as it is sine square 2 sine alpha cos alpha minus sine square alpha as it is 2 alpha upon alpha raised to 4 d alpha. Right, if I prime is to maximum, so it's equal to 0. So if you simplify this term, it's very simple. You can find that the tan alpha is equal to alpha. So graphs are plotted for y is equal to alpha and y is equal to tan alpha. It shows the secondary maxima are not exactly at the halfway between the two minima, but are slightly displaced towards the central maximum. So here this is the minima pi, 2 pi, 3 pi. This is the maxima 3 pi by 2, 5 pi by 2, 7 pi by 2. So according to this equation, if you take the y is equal to alpha, so y is equal to alpha is nothing but the linear line y is equal to alpha. Okay, so you need to put the alpha different value. Okay, and similarly y is equal to tan alpha. So you know, if you know the tan alpha, it shows like this type of curve. So you can put the different value of alpha here and get the function of I. You can similarly you can get this one. So if you see here the pi, this is the secondary minima, this is 2 pi, this is the secondary minima, this is the third secondary minima. But if you are, this is pi and 2 pi, here you will get the 3 pi by 2 minus 3 pi by 2, here you will get the minus 5 pi by 2, here you will get the minus 7 pi by 2. Similarly here you will get the, this one plus this one 3 pi by 2, this is 5 pi by 2, and this is 7 pi by 2. Okay, so third one is secondary minima. So here for the minima, this is the destructive interference, and you know the condition for the secondary minima, a sine theta is equal to n lambda. For the destructive interference, the phase difference is alpha is equal to pi upon lambda a sine theta. So again alpha is equal to pi upon lambda, a sine theta is equal to n lambda. So lambda lambda will cancel out. Alpha is equal to n pi. So alpha is equal to pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. So alpha substitute in the equation I prime I 0. Alpha is equal to pi, 3 pi. So it will be intensity 0. So that's why secondary maxima, this one, this one, this one, the intensity is 0. For the secondary minima, the condition is pi, 2 pi, 3 pi. The position for second and third minimum are given by the, as you know, the lambda by a, 2 lambda by a, 3 lambda by a, up to alpha, or you can also write pi, 2 pi, 3 pi for difference value of the sine theta. Okay, so up to now we learned the central maximum at condition is alpha is equal to 0. Secondary maxima occur at alpha is equal to 3 pi by 2, 5 pi by 2, 7 pi by 2. Secondary minima occur at alpha pi, 2 pi, 3 pi, and 4 pi, 6, 5 pi, 6 pi, and so on. So here your topic for the intensity distribution of single slit diffraction is over. So next time in the next lecture we will learn the double slit diffraction. Okay, thank you.